Hi, this is Mrs. Downey, and we're doing Algebra 2, Chapter 11, Part 2. This is 11.5 through 11.9. And the first thing we're going to do is we're going to find the mean, the median, and the mode of the data set. We're going to round to the nearest tenth. So the first thing you want to do is put all of these numbers in order. And tangled up here. And the first thing we want to do is put them in order. So we've got a 1. Whoops. A 1 there. A 2. A 3. A 7. Another 7. And another 7. And next we have an 8. 12, 14, and then a 15, and another 15. And that's everything. So after you get them in order, you want to go ahead and add everything up. So when you do, you get that these all add up to equal 91. And then you want to divide that, and this is for our mean, by the way, which is x bar. We represent mean or average with x bar. So 91 over the number of elements. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 11 elements. So when you divide 91 by 11, you get 8.2727272, so on forth. And it says to round to the nearest tenth, which is 1 decimal place. So we're going to 1 decimal place here. That means look at the next position. It is 5 or higher. It is actually higher than 5. So we're going to round up. This becomes approximately 8.3. And that's our average, our mean. Okay, the next thing they ask us to find is the median. So what we want to do is start at the outside and move inwards. So we're going to go 15 and 1. Those go together. Now let's move in again. 2 and 15. Next is 3 and 14. 7 and 8. And then 7 and 12. 7 and 8 is next. And then the last thing we have here is 7 in the middle. Okay, because we had just one item in the middle, that becomes our mean, or excuse me, our median. And so our median equals 7. Now the next thing we want to find is the mode. What occurs the most often? So when we look at how many times two numbers occur, well, 1 occurs once, 2 occurs once, 3 occurs once, 7 occurs 3 times, 8 occurs once, 12 once, 14 is once, and 15 is 2 times. Which one occurred the most? 7. So 7 is our mode. Whatever occurs most is your mode. Okay, so there's our answers. We had our mean is 8.3, median is 7, and mode is 7. Number 2 says find the outlier in the set of data. Well, an outlier is a number that is way far out of bounds of most of the other numbers in your data set on either end, the beginning or the end. So let's put everything in order from least to greatest. We start with 12. Next we have a 13, a 14, 15, 19, 21, 22, and 35. Now you would notice that 12 and 13 are pretty close to the same. You know, they're 1 different. 13 and 14 is 1 different. 14 and 15 is 1 different. 15 and 19 is 4 different. 19 and 21 are 3 different. 21 and 22 are 1 different. And then we look between 22 and 35, we're 13 different. So see, 35 on the end is vastly different than all the others. So that is our outlier. What that does is it would skew our data when taking an average. You know, it would give us some false readings about really what is our data doing. It's mostly between 12 and 22, but when you throw an outlier in the picture, it really can hide some concepts about our data. So the outlier, it's on either end, either the beginning or the end, and it is greatly different from a majority of your data. So 35 is our outlier. This is to make a box and whisker plot of the data. So you want to look at your beginning and your ending. So our smallest number is 10 and our largest number is 29. So I know I'm going to need a number line from 10 Okay, so let's now mark these. This is 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. And actually, hold on. Let me see if I can get a better graph for you here. Okay, here I just created one within my software. So let's get rid of this guy. All right, so there we have. This will cover our beginning and ending values from 10 to 29. See, there's 10 and 29. So let's go ahead and mark those endpoints. At 10, we're going to put a dot. And at 29, we're going to end our data. So there's the first step to making our box and whisker plots. The next thing I want to do is put everything in order from least to greatest. So it's going to be 10, 11, 12. 15, 18, 19, 24, and 29. All right, so now we want to get our median, and that means we're going to, again, go from the outside in. So I like to just put a finger on each end and keep moving inwards one at a time till I get to my middle point. So next is 11 and 24. And next is 12 and 19. And then we're left with 15 and 18. So to get our median, because we're at two numbers, we're going to have to add them and divide by 2. So we want to average the 2. And when we do, we get that is 16.5. So our median is at 16.5 right here. There's our median. Next, we want to get our first quartile. So we're going to divide our data in half and do this again. Move in, and there's our middle, 11 and 12. So add those and divide by 2, and you have 11 and a half. There's my first quartile. So I've got the left half of my box now. Oops, it's not very pretty. And I can draw my whisker. Now I'm going to do the same thing over here. So I'm going to go 18 and 29. And now 19 and 24. Add them and divide by 2, and I have 21 and a half. So right here is the third quartile. So I'm going to draw my box to there. So here's my box, and there's my long whisker. And there's my box and whisker plot. And that's it. Okay, we're continuing our Chapter 11 Part 2 review for the test for Algebra 2. This says find the values of the 30th and 90th percentiles of the data. So the first thing we want to do is order this data from least to greatest. So we start with 100. The next we've got another 100. And then next would be 105. Then 113. Then 129, 132, 146, 152, 176, and 200. That gives us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 items total. Now, they want to know what's the 30th percentile and the 90th percentile. Well, for the 30th percentile, we're going to convert that to 0.3, like 30%. 0.30 is just 0.3. And to get to the 30th percentile of our data, we're going to multiply that times the number of items. So where do we sit? Where is the 30th percentile in our list of 10 items? So that's going to be equal to 3. That means it's the third item. So 1, 2, 3. So my 30th percentile is 105. So there's one answer. Now we're going to work the next one pretty much the same way. So 90th percentile is 0.90, which is equal to 0.9 times 10, which is equal to 9, which means our 9th item. So there was 3, 4, 5, 6, 7, 8, 9. So our 90th percentile is equal to, I forgot what it was, 176. And that's how you work those. Okay, number 5 says what are the mean, the variance, and the standard deviation of these values. So the mean, the variance, and the standard deviation. Round to the nearest tenth, so we know we need 1 decimal place. Alright, so the first thing we want to do is add them together. So when you add 11, 11, that's 22 plus 10, that's 32, plus 7 is 39, plus 5 more is 44, plus 4 more is 48. So we have 48 divided by how many items? 1, 2, 3, 4, 5, 6. So our mean is equal to 8. Okay. So we've got the mean. Now we need the variance. So for the variance, we're going to have to put these in a box and calculate some values. I like to put things in order, so excuse me, let's go 4, 5, 7, 10, 11, and 11. Okay, so there's our first column. And we're going to have a box of 4 columns here. Now, the next thing we want to do is calculate the average, or the mean. We've already done that. So this is x. This is going to be our x bar, our mean, which is 8, all the way down. For all of the items, they have the same average. The next column is our x minus x bar. So that means we're going to subtract the 2 columns and find the difference. So 4 minus 8 is negative 4. 5 minus 8 is negative 3. 7 minus 8 is negative 1. 10 minus 8 is 2. 11 minus 8 is 3. And the same. Excuse me. Now our last column is to square that difference. So this is going to be 16, 9, 1, 4, 9, and 9. Now when we find the variance, which is sigma squared, we know it's just going to be this column, take the average, right? So what is the average? So when we add all of these together, we get 48. And now 48 divided by 6, that's the number of items, equals 8. So it's coincidence that not only was our mean 8, so is our variance. Now to get our standard deviation, we're just going to solve this, right? So 0 squared equal 8. I'm sorry, sigma squared equals 8. Then what will we do? Take the square root of each side, and now we get sigma equals radical 8. Or when you solve radical 8, it's about 2.8. So that's our variance, or excuse me, our standard deviation. So there's our three answers. Our mean is 8. Our variance is also 8. And our standard deviation is 2.8, about 2.8. Our next problem asks us to use the graphing calculator to find the mean and the standard deviation of the data round to the nearest tenth, which is 1 decimal place. Okay, so let's get our graphing calculator. This is what we use in our class here. All right. So we're going to first clear everything out. Whoops. So hit clear. And we want to go to our stat. Now in stat, you see that we're first going into edit. That's exactly what we want. So press enter. And if anything is in your list, you'll want to arrow up, hit clear, and hit enter to clear that list out. Now let's start typing in list 1. Okay, so we're going to type all of these figures. 17, enter, 9, enter, 20, enter, 22, enter, 22, enter, 8, enter, and 13. Enter. So now I've got my list 1 populated with 9, 17, 9, 20, 22, 22, 8, and 13. Now let's go back to our stat screen, and we want to right arrow over to calculations right here. And we want to select the first one variable statistics. So I'm just going to press enter. And there it is again, one variable statistics. I'm going to press enter. And it gives me my mean right there and my standard deviation right there. This sigma x is my standard deviation. So my mean is 15, said 1/10, so 0.857, which rounds up to 15.9. So there's my mean, and my standard deviation is the sigma x down there next to the last line, which is equal to 5.488. Well, to round to 1 decimal place, it's going to have to go to 5.5. So sigma, or standard deviation, is about 5.5. We want to change those equal signs. So there you go. There's your 2 answers. Okay, here's continuing our Chapter 11 review for Part 2. Number 7 says identify the type of sampling method used. A principal gets on the school intercom and asks all students to log on to a website and take a survey over school dances. So this is called self-select sampling. Our next question, number 8, says state the bias in the following question. Don't you like summer better than winter? Well, when you're forcing somebody to say yes or no, you are leading. This is a leading question. So this is a leading bias. You are leading your question by saying, don't you like? Okay, our next question says, number 9, restate the following question so it is no longer biased. So when we look at it, we see, wouldn't you agree? So there's leading. That the awesome rap videos, so awesome, that's loaded. You're loading your question with all those adjectives, trying to sway their opinions, are much better than boring country videos. So there's another loaded word. So we need to get rid of those 3 things. So it's better off to say something like, do you prefer rap videos or country videos? Or how about this? Let's combine that. Do you prefer rap or country videos? There it is. That's rewriting. It's no longer biased. There's nothing to sway their opinion or to force them to a yes or a no. Number 10 says, a survey of high school juniors found that 82% of students plan on attending college. If you pick 3 students at random, what's the probability that 2 plan on attending college? Round to the nearest percent. So that means we're rounding to a whole number, like that. So the first thing we want to do is figure out, we know we've got to find our P, our Q, our N, and our X. So for our P, it's what is the probability? Our probability, they say that 82% of the students plan on attending college. That's your P. If you pick 3 students at random, well, there's your N. That's how many, your number of trials. So we've got P, we've got N. What is the probability that 2? Well, there's your X. That 2 plan on attending college, round to the nearest percent. So the only thing left to calculate is our Q, and we get the Q, that's our fail rate. Well, probability is like the pass rate, Q is the fail rate. So if you take our pass rate, 82% from 100, we get 18. So our Q is equal to 18%, or 0.18. So now we've got all of those. Now we're going to plug them into our formula. So we know that P of X is equal to NCX times P to the X power times Q to the N minus X power. So when we plug these numbers in, we'll get our answer. So P of 2 is equal to 3C2 times 0.82 to the X power, which is 2, times my Q, which is 0.18 to the 3 minus 2. Now 3 minus 2 is 1, and 0.18 to the first power is just 0.18. Now we've got to calculate this. So the combination goes 3 factorial over 2 factorial to the 3 minus 2 factorial times 0.82 squared times 0.18. And we'll keep going. The 3 minus 2 here is just 1 factorial, which is just 1. So now we have 3 factorial over 2 factorial, which we can rewrite as 3 times 2 factorial over 2 factorial. Those cancel out. So we're just left with 3 times 0.82 squared times 0.18. And when you plug that into your calculator, we have 3, whoops, turn it on first, on, clear it out. So we've got 3 times, open parenthesis, 0.82 squared, close parenthesis, times 0.18. Enter. And you get 0.363096. So it's about a 36% chance. And that's your answer. Number 11 says the bar graph shows rents paid per month for apartments in an urban neighborhood. The curve shows that the rents are normally distributed. So it says estimate the percent of apartment residents who pay from $650 to $749 per month. So let's go to that range and mark it off. Here's $650 and there's $749. So it involves all of this between my two lines here. So if you look at the percent in the first bar, that's at about a 43%. And we're going to add to that this next bar right here, which is at about 25%, which equals 68%. And that's our answer. Our last problem here, number 12, says the scores on an exam are normally distributed with a mean of 84 and a standard deviation of 10. So these are important. There's our mean and our standard deviation. Now we can draw our graph. We know that the mean is 84. And from there, we can get our standard deviation. So if this is our mean, which I'll mark mean, then we know plus 1, plus 2, and plus 3. So one standard deviation is going to be 94 because we're adding the 10 units of standard deviation. And for the second, we're going to add 10 again to 104. And for the third, it's going to be 114. That's also 10. Okay, and then over here, actually I'm going to erase these. Just know that every unit, it's adding the standard deviation. Now we're going to subtract 1, subtract 2, and subtract 3 standard deviations. So this one is going to be 74, 64, and 54. Now we know that we can draw our curve. Alright, and we know that 68% of our data falls within one standard deviation, so that leaves 34% here and 34% here. And in the two standard deviations, we have 27%, and so that divides out by 2, 13.5, and 13.5. And then that last little bit is 2.35, and I just always remember is 2.35. Okay, and there's 0.3% not accounted for. That must be our outliers, another one. So the I had to switch videos here. So recounting, okay, we've got our graph. We've measured out our standard deviations in both directions. We've got a mean of 84. Oops. A mean of 84, and our standard deviation, each one is minus 10 and plus 10, both directions. And so now we've drawn our curve, and we have our percentage breakdown of each deviation. Now, they ask us, let me erase from it, what percent of the scores are less than 94? So let's look. Here's 94. They want to know what percentage of our scores are less than this. So because we didn't account for that 0.3% that's missing out of our percentages here, we can't just add 2.35, 13.5, 34, and 34. We can't do that because there's that portion that's missing that we can't say what it is or what it isn't. It's just not there, so we can't say it's distributed evenly. Or so what we have to do is now realize that half of this data is 50%, right? So let me change colors. Half of this data, here's half. That means that this half is 50%. Right? And that the other half is 50%. That we can be sure of. Now, what we want to do is add this 50% plus this much. Right? So, if we have this 50% plus this 34, we're going to have our answer. So, 50 plus 34 is 84. So our final answer, what percent of the scores are less than 94? That's going to be 50 plus 34 equals 84%. And that's our answer. That's everything. Study hard and work well. Good luck on the test.